वेलकम बैक टू माय डियर फ्रेंड्स टू द टेक सिविल लर्निंग। आप सभी को टेक सिविल लर्निंग में स्वागत है। एज यू नो, आवर चैनल इज कंटिन्यूसली इंसिस्टिंग विथ प्रोवाइडिंग प्रैक्टिकल एजुकेशंस एज इट इज़ आवर मोटो. So my dear friends, if you have not subscribed my channel, please subscribe it so that you will get the notifications once I upload the video. So today we are going to start a new series of lectures from the most important subject, that is fluid mechanics, from the civil engineering field. So let's start. Here the fluid mechanics is nothing but the dealings of fluid, and we will study about the temperatures and effect of the forces on the fluid. So here the term to be understand is fluid. Fluid is nothing but the any substance which can follow, right? Either it may be the liquid or gaseous in states, but the substance which can follow. Here the term to be understand is substance is nothing but a matters which occupy some space, have a mass, is means nothing but the substance. And the term to be understand is what is follow. Follow is nothing but means changing of positions with respect to its position. So means changing from one place to another place is nothing but the follow. So ultimately fluid is nothing but the substance which can follow, and dealing of the temperatures and the pressures and its forces effect on the fluid is nothing but the fluid mechanics. So in this fluid mechanics we will categorize into the different units. So let's see what we are going to study in this series of lectures. So in unit 1 we will deal about the physical properties of fluid. As you know, means there are the different physical properties of fluid, like we'll deal about density, mass density, right, viscosity. We'll deal about the surface tensions, right, etc. We're going to discuss about clearly once we're going to start the series. So today we'll just introduce what we're going to study in this series of lectures. Similarly, we'll deal about the Pascal law, what are the applications of Pascal law, where it is used. As you know, our channels always try to relate the realistic concept in the theoretical area. So we'll deal about the hydrostatic law, what are the statements of hydrostatic law, its derivations. Similarly, manometers, means what is manometers, what are the different types of manometer, numerical based on its. Similarly, we'll going to deal about the measurement of pressures by the pressure gauge. So all over from the unit 1 we'll cover all these topics. Once we're going to start the series, we'll provide you a proper handwritten notes so that you can understand the concept clearly and it enhance you to clear all the competitive exams. So once the lectures started, we will provide all the materials. So these are the terms which we will going to cover in unit 1. So let's see what we are going to cover in unit 2. So here unit 2 will especially deal about the hydrostatics, right, means hydrostatic force on the submerged body planes, right, either it may be the horizontal, vertical or the curved surface. We will derive the different types of formula for the horizontals, vertical and the curved surface. Similarly, we will going to have some numericals based on the hydrostatic force. Similarly, we will deal about the buoyancy and the flotations, which is very important in the fluid mechanics terms, and the metacentric and the metacentric height is an important term to be understand in the fluid mechanics, and it is very useful for the competitive type of exams or university levels types of. So hydrostatics, and these hydrostatic force on the submerged body, like horizontal, verticals, is very important for the university level of students. It is a type of questions which is frequently asked. So need to be here high concentrations with a high focused. So it's my request to all of you, please focus or understand the concept easily so that it enhance your knowledge and build up your comprehensive knowledge in the fluid mechanics. Comprehensive knowledge is very important for the build up. So similarly, this all the topic belongs to unit 1. So we'll going to deal once the lectures of the series of lectures started. So let's see in unit 2 what we're going to deal about. In unit 2, yes, of course, we'll deal about the fluid kinematics. Here in this ones we'll deal about the classification of flow, means what are the steady, unsteady, right, uniform, non-uniform. So we'll understand all these all these topics very clearly, right, and I will try my best level to connect you to the practicals level so that it's give you ease in study and it's really makes you happy so that you understand the concept very well. So what are the applications of steady what are the assumptions to be considered in a steady flow, what are the means we'll going to deal about the different classification of flow with the practicals applications, and where it can be seen, where it can be appeared right in the real life. So we'll going to deal about all these things in the classification of flow. Similarly, we will deal about the continuity equation for the 1, 2 and 3 dimensionals. As you know, continuity equations, that is a1 b1 is equal to a2 b2, right. So we will deal about all these things very clearly. Continuity, what are the applications where the continuity equations can be applied, or what are the applications of the continuity equation for the 1, 2 or 3 dimensionals. The continuity equation for 1, 2 or 3 dimensional is continuously types of asking questions in the university level students. So we will derive all the required derivations for the 2 or 3 dimensional types of flow for the continuity equation. Similarly, we will deal about the description of fluid flow, like the streamline. What is a streamline? Path lines means what where the path line can be seen or appeared, a streak line. So we'll going to deal all these topics in the vicinity in the clarity manner. Along with, I will provide you handwritten notes so that it enhance you to build up the knowledge, and it may increase your understanding capacity, so that and you can prepare your notes very clearly. So my main theme, or the main theme of our channel, is to connect the students to the practical level by providing the proper handwritten note, so that you can write or you can study very clearly. So if you have any doubt regarding all these things, you may put your thought in the comment section, so that I can solve. If you need anything, like if you have anything, or if you need anything, I have already substituted my link in the comments description box. Please go through that ones and be connect with us, so that you can understand the concept very clearly. So let's see what we're going to deal in unit 4. Yes, in unit 4 we will deal about the fluid dynamics. That's Bernoulli equations, which which has lots of applications in practical, like venturimeters, all those things. We'll deal about the pitot tube in this one. So we're going to derive the Euler's and the Bernoulli equations for the follow. Here we will deal about the momentum equation, right, bent in pipe. As you know, momentum equation, bent in pipe, Reynolds experiments. Why Reynolds experiments? What are the uses of Reynolds experiments? So all these topics are very relevant to the practical levels. Understanding these things enhance your really technical knowledge in the civil engineering field. As civil engineering field it need to be understand very clearly with the practical levels, because we must have to be practicals in the civil engineering. So we will understand all this concept very clearly once we are going to start the series of lectures along with the proper note. So my main theme is you can write notes very clearly along with the understanding. Similarly, we will deal about the what is laminar flow, turbulent flow, what are the characteristics of laminar flow, turbulent flow, on the factors, on what factor laminars and turbulent flow depend upon. Similarly, we will deal about the measurement of flow, closed conduct flow, right, friction loss, what are the major friction loss, minor friction loss, or lots of problem we will deal on this topic. So once we are going to start the series, I hope I will provide you as soon as possible, so that it may help you very clearly. So this is all about the unit 4, and unit 5 will deal about the boundary layer theory. And boundary layer theory can be easily seen or appeared in the practical life, as it is not hypothetical study. It can be seen and observed. So in that ones we will deal about the boundary layer concept very clearly. That in the same manners we will derive a formula for the Prandtl contributions. So we will derive Prandtl contributions formula. Similarly, Bohm-Karman momentum integration equations. So we will derive all this formula, and we will have some numericals based on the university levels or the competitive types of exams. So my main motto of our channel is to connect you and to provide you the best quality of education, and not the quantity of education, because quality of education is need to be understand very clearly, as it is the part and parcel for the civil engineering field. So similarly, in this ones we will deal about the laminar and the turbulent flow, what are the layers, when the flow occurring. So where the at what condition laminar is to be considered, at what condition the turbulent is to be considered. So at the same time we will deal about the control of boundary layers and the drag and the lift problems. So my dear friends, these are the introductions, or we can call it, these are the syllabus which we are going to cover in the fluid mechanics. So once I will going to start the series of lectures, I will continuously provide you proper handwritten notes so that you can write it in your notebook and you can means clear all your competitive exams, as I will provide all the details regarding to the topic, and I will try to my best level so that you can understand the concept very clearly. So once the series of lecture starts, please follow us. If you have any doubt, please go through that once, or if you want to contact us, please click on the WhatsApp link which I have already substitute in the descriptions box, so you can follow us. So be with us, study hard, learn, and don't forget to follow us. So thank you. We'll meet in the next series of lectures. So thank you, and please don't forget to subscribe. Thank you.